The topic for today is solving systems by substitution. In the theory, we have that sometimes, page 300, I'm going to write it in here, page 336. Sometimes it is difficult to identify the exact solution to a system by graphing. In this case, you can use a method called substitution. The goal when using substitution is to reduce the system to one equation that has only one variable. Then you can solve this equation and substitute into an original equation to find the value of the other variable. We have some steps for solving systems of equations by substitution. The step 1 is to solve for one variable in at least one equation if necessary. The step 2, we need to substitute the resulting expression into the other equation. The number 3, we solve that equation to get the value of the first variable. And the last step, the number 4, okay, they are 5, but the number 4 is only to write the solution. So in the number 4 is the last that you are going to solve something. So you need to memorize these 4 steps at least to solve these kind of exercises. In the number 4 is to substitute the value for the first variable you found for the first variable, and you replace it on the original equation to find the value of the other variable. When we have the value for both variables, we write the order pair, okay? The order pair for the possible solution. And one additional step that it's not included on the book, but you need to do it, is to prove that the solution you found is the solution for the equation 1 and for the equation 2, okay? So if it's a solution for both equations, then you can say that the order pair is a solution for the system of equations. For example, in the number 1, we can solve the number 1. In the same page, 336, we need to solve a system of linear equations by substitution. So they ask you to solve each system of equations by substitution. Then I'm going to write the text. Maybe, okay. The topic is solving systems by substitution. I'm going to write in here. Solving systems by substitution. Okay. And now we are going to start with the example 1. Solving a system of linear equations by substitution. I'm not going to write again this because it's the same topic we have. For the exercise A, we have this. The first one is y equal 2 times x. And for the second example is y equal x plus 5, okay. How are we going to solve this? In the step 1, we need to find the value for the variable y, okay? We need to isolate the variable y. In this case, we already have it. Y equal to x and y equal x plus 5. So you can see that both equations are solved for y. Y equal to x, I'm only going to copy again, and y equal x plus 5, okay? Then you can say that both variables are solved for y, okay? And
Mister, excuse me.
Tell me.
Kimberly said that, Mister.
I'm listening.
Kimberly said that the platform Zoom,
you can see that the step 1, we already have it. In the system of equations, they already give you the value solved for y. That's only the step 1. Now in the step 2, we need to replace the value in the other equation. For example, I have 2 in here. I have one value of y that is equal to x, and I have the other value for y that is equal x plus 5. So I can replace one of these values in the other equation. That's the idea of this. Substitute the value for one of the equations in the other one, okay? Because we don't have to work with two variables. The idea is to work only with one variable to find the answers first, and later we use this to find the other one. For example, I don't want to work in here with y and x, the same in here. So I'm going to take one of this and I'm going to replace it. For example, if I replace 2x in the value of y for the other variable, you can see that both of them are equal y. So I can perfectly replace and say that 2 times x is going to be x plus 5. So I form only one equation. And what I need to do now is only to find the value for x. Then I have 2 times x minus x equal 5. The x is positive, so I pass it to the other side, negative. And when we subtract 2 times x minus x, you obtain that x is equal positive 5. But we have 2 steps in this. Only to replace is the step 2, and I think that when we already find the value, when we start solving the exercise, doing the procedure to find the value, is the step 3. Yes, so when we solve for x, we obtain that it's 5. Now I'm going to copy the step 4. What is the step 4 then? Remember, there are 2 variables that I need to find. In this case, I only have x, so I need to replace the value that I obtained for x in the original equations, in one of both equations, to obtain the value for y, the other variable, okay? In this case, we are going to replace in the first one, y equal 2 times x, so y is equal 2 times 5. Then you can say that y is equal 10. And the step 5 is only to write the solution you find, okay? So what are the 2 values we have? 5 for x and 10 for y. What is the last step we always solve in the system of equations? Maybe don't write the step 6 because they know that you already understand that you have to prove the solution. You need to prove this on these equations. So we are going to replace the ordered pair in the equations to know if it's really, okay, the solution for the system of equations. So if you have that y is equal to 2 times x, you are going to change these values, and y is 10 equal to 2 times x, that x is 5, right? So, and in the other one, you have that y is equal x plus 5. You know that y is 10, so 10 equal 5 plus 5. So you have that 10 is equal 10 in this case, and in the other one you have the same, that 10 is equal 10. Okay, so what is the idea of this? You solve the exercise, but when you have the possible solution, in this case the ordered pair 5, 10, you prove it, and later what is the last step? We say that the ordered pair, this one, is a solution for the system of equations. The ordered pair is a solution for the system of equations. Okay, maybe we forgot to write the order pair. We can write it. The order pair 5, 10. We write what is the order pair we are talking about. Okay. And here we have the result of this. Maybe I can draw. This is only proving the value for the variable, the values for the each equation. So I'm going to okay, I'm going to select this so you remember that this is the additional step only to prove the solution. Okay, this is for the example 1. Maybe we take some time in here because the idea is for you to understand the concepts when you first study this topic. Then we can go to the example B and C, but I'm going to ask you if you have something in your mind in this moment. We are going to solve this exercise B, and the other equation we have y equal x minus 4. Okay. The step 1, what is the step 1? Only to find the value for one variable. Step 1, I only need one equation to find the value for one variable. Look, we can find the value for y or x and have this expressed in terms of the other variable. In this case, you already have this isolated. You have this solved for y, so the idea is that you replace this in the other equation. The value for y is x minus 4. So this is what we are going to replace in this variable that we have in here, okay? So in the step 1, we isolate for one variable, so we already have this, and we are going to use it. Step 2, we replace what we found in the other equation. So in this step 2, I'm going to replace this on the first equation, 2x plus x minus 4 equal 5. Now you can see that we only have the variable x. We are not working with the variable x and y anymore. The idea of substitution is that you don't need to solve for both variables at the same time. You are only going to work with the variable. It could be x or y, depending on the variable you substitute, okay? The variable you replace. Step 2 is only to replace. The step 3 is when we start solving, sorry, for the variable. In this case, the only variable that I want to find is x. So I have that 2x plus x is equal 5, and the negative 4, I'm going to pass it to the other side, so it's positive 4. 2x plus x is 3x equal 9. So if I find the value for the variable x, I pass the 3 that it's multiplying to the other side to divide. So 9 divided by 3, x equal 9 divided by 3. So we already have that x is equal 3. Now we can go to step 4. I'm going to write this in here. Okay. So in the step 4 now, I'm going to write in here. In the step 4, we already have the value for one variable, so I need to replace this to find the value for the other one. We are going to use the x equal 3 to find the value for the other variable. We can replace it in here, for example, because it's the easiest one. Look that if I replace this in here, I need to multiply 2 times 3 plus y, and later pass the 2 times 3 to the other side. So then when we replace, we are looking for the easiest one. I'm looking for the variable where I can replace the value and obtain the answer easily. So I'm going to find the value for the other variable using x minus 4. Then for y, you have that x is 3 minus 4. So y is going to be negative 1. This is what we obtain in here. And what is the step? What is the step 5? We are going to replace the values to form the ordered pair. 3 for x and -1 for y. Okay. Then we already have the possible answer, this one, but we need to prove that this is the solution. So we substitute the values, replace the values in the original equations. Then I'm going to prove in both equations 2x plus y equal 5. Then 2 times 3 plus -1, right? We have -1 for y. So the minus is going to eliminate. This is going to be equal 5. And we know that it's true, right? Because 6 minus 1 is going to be 5. Now for the second equation, we have that y is equal x minus 4. The value for x is 3 minus 4. You obtain, -1 in here. -1 is equal 3 minus 4, so you have that -1 equal -1. And in here you can say that 5 equal 5. Okay. So we already proved that this is the solution for the system of equations. So I'm going to move in here so we can complete the very last step. And we say that the ordered pair, what is the ordered pair? 3 for x and -1 for y is a solution for the system of equations. Okay, you can see that maybe we take some time in here, but this is for one exercise, the green part, and the blue part is the other one. We solve 2 exercises and we write all the steps. The difference, guys, is that you are not going to write in each exercise step 1, step 2. Okay, only if you need it. If you need it, you can write it, but it's not necessary. What it's necessary is that you learn the steps. Okay, you need to memorize the steps. How are you going to do to solve these kind of problems using substitution? That is important, but for you to write each step is not. Okay, so the important is that you find the value for both variables and you prove that solution. So if you don't have any other questions, guys, I'm going to finish in here the class because we don't have much time. Okay, so I'm going to stop the recording and we continue tomorrow with this topic. Okay.